Right, done. Next question. Let x is equals to 1, 2, 3, 4 and so on to n. X contains exactly 2n elements, friends. Okay. Let A is subset of x and B is subset of x. How many ways we can choose A comma B such that A delta of B is equals to 2, 4, 6, 8 and so on 2n minus 2, 2n. It means that we are taking exactly all even numbers, friends. Okay. So options for this problem: 2 power n, 2 power 2n, 4 into n, and then n. How many ways we can choose A comma B such that A delta B contain all are even numbers? Means I am expecting all even numbers in only A delta B, friends. Right, friends? Okay. So the time allocated for this question is over. Let me explain how to solve this problem. A delta B must contain all are even numbers. All are even numbers, friends. Your set X contains total 2n elements. X contains total 2n elements, where A is subset of X and B also subset of X, friends. Observe how I am going to discuss this problem by taking, for all small x belongs to capital X, for all small x belongs to capital X, there are two possibilities for X, friends. That one is it may be even number or it may be odd number. So for all x belongs to capital X, there are two possibilities for X. If x is even number, then that even number must fall under A delta B, friends. Even number must fall under A delta B. If x is odd number, then that odd number cannot sit in A delta B. It cannot sit in A delta B. It should be outside of A delta B, friends. Okay. So these are two cases I want to discuss, friends. Okay. Let me take first A delta B Venn diagram. Suppose we are having A comma B. So A delta B is nothing but A minus B union B minus A. Alright. A delta B is nothing but A minus B minus C. So this part is called A minus B. This part is called B minus A, friends. B minus A. So whenever x is even number, it must fall either in A delta B or it may fall in B minus A, friends. Okay. Every even number belongs to either A minus B location or B minus A location. So therefore, if x is even, then either x belongs to A minus B or x belongs to B minus A, friends. These are two possibilities. Either x belongs to A minus B or x belongs to B minus A. Means every even number having how many possibilities? Two possibilities. Now kindly recall basics which I covered in the last class. Okay. Let me write those basics, friends. Suppose if I have x1, x2, x3 and so on xn. If there are n variables are there, and if each variable having two possibilities, either absent or present, like this. There are n variables and each variable having two possibilities. then the total number of combinations possible is equals to 2 to the power of n. You always remember this logic, friends. Complete discrete mathematics depends on only this logic. Okay. Here 2 is called base. Base always indicates number of possibilities for each variable. N is called exponent. Exponent always indicates that how many such variables are there. Okay. Base means number of possibility for each variable. Exponent is nothing but number of such variables. How many variables we have? N variables. That's why it is 2 power n. In this example, if x is even number, then that x even number having two possibilities. Either it may fall under a minus b or it may fall under b minus a. Then only we will get a delta b is equal to even numbers, friends. Therefore, every even number is having two possibilities. Every even number is having two possibilities. So, two possibilities. But how many even numbers are there? N even numbers, right? Therefore, 2 to the power of n. There are 2 to the power of n ways we can place all even number into a delta b. Clear, friends? All even number placed into a delta b in 2 power n ways. Fine. Now I am introducing some important point. Please listen, friends. 2 to the power of n ways we can place all even number into a delta b. Then what about remaining elements? Can you give guarantee that remaining elements are not there in a delta b? I am asking the question. You placed all even numbers into a delta b. Now a delta b contain even numbers. It takes 2 power n ways. But how do you ensure that a delta b does not contain remaining elements? How do you ensure that a delta b does not contain remaining elements? We can give guarantee that by placing remaining element into outside of a delta b. So outside of a delta b means, look at here, friends. So if it is odd number, it must fall under a intersection b, or it may fall under outside of a union b, like this. Okay. So therefore, if x is odd number, x belongs to a intersection b, means this region, x belongs to a intersection b, or x belongs to a union b whole bar. A union b whole bar means it should be outside of a union b, friends. Okay. So outside of a union b I can show like this. Just look at this one. This region is called outside of a union b. Clear? So therefore, every odd number having two possibilities. One is a intersection b or a union b whole bar. Therefore, total number of possibilities for odd number 2 power. How many odd numbers are there, friends? N odd numbers are there. Therefore, 2 power n. So I can ensure that a delta b does not contain even numbers. Sorry, I can ensure that a delta b does not contain odd numbers only by placing odd numbers into this location. Okay. So here this is the location where we are placing even numbers. This is the location we are placing odd numbers. Now what is the final answer for this question? What is the final answer for this question? To understand final answer of this question, we need some basics, friends. Okay. That's why first I will discuss basics. Afterwards I will explain what is the final answer for this question. Okay. Please listen basics also. I will give time for writing notes, friends. You please kindly cooperate another 2 minutes. Friends, just assume that there are 3 cities like Hyderabad, Pune and then Delhi, friends. Okay, Hyderabad, Pune, Delhi. Assume that from Hyderabad to Pune we can reach in 3 different paths. Hyderabad to Pune we can reach in 3 different paths, and Pune to Delhi we can reach in 2 different paths, friends. We can reach from Pune to Delhi in 2 different paths. Now if I ask the question, how many ways we reach from Hyderabad to Delhi via Pune? How many ways we reach from Hyderabad to Delhi via Pune? So in this problem, you have to understand what is a task. Task is reaching from Hyderabad to Delhi, friends. Okay, the task is here. reaching from Hyderabad to Delhi. This is called your task. But the task you are divided into two subtasks. What are the subtasks? First, you have to reach from Hyderabad to Pune, correct? First, you have to reach from Hyderabad to Pune. This is called task 1. This is called task 1. After reaching Pune, don't stay there. Reach from Pune to Delhi. This is called task 2. Clear, friends? Task 2. If you complete these two tasks one after another, then only the whole task will be completed. Correct, friends? Let me ask you a question. How many ways you can reach from Hyderabad to Pune? Obviously, there are 3 different paths are there. Out of 3 paths, I have to choose one path to reach from Hyderabad to Pune, right? Therefore, from these 3 paths, I can choose one path, friends. How many ways I can choose? 3C1 ways. That equal to 3 ways. Similarly, after reaching Pune, from Pune to Delhi, I can choose one path, friends. That is 2C1. Now, what I am going to ask, what is your answer for this question? Is your answer is 3C1 plus 2C1 or is your answer is 3C1 into 2C1? What I am trying to ask you, is your final answer is 3C1 plus 2C1 or is your final answer is 3C1 into 2C1? Obviously, it must be 3C1 into 2C1. The reason is, with respect to first path, we have 2 different paths. With respect to second path, we have 2 different paths. With respect to third path, we have 2 different paths. Therefore, number of ways to finish this task is 3C1 into 2C1. That equals to 6, friends. So, how many ways we reach from Hyderabad to Delhi via Pune, which is nothing but answer is 3C1 into 2C1. So, if the whole task is completed by completing subtask one after another, then the total number of ways to complete the task is number of ways of completing subtask 1 followed by number of ways to complete subtask 2. Clear, friends? Therefore, answer is 3C1 into 2C1. Okay. Now, apply this logic, friends. In this example, what is your task? Your task is placing all even numbers into A delta B. Correct, friends? Your task is you have to get all even numbers into A delta B. That is your task. But the task we are finishing by placing even numbers into A delta B followed by remaining odd numbers into remaining place. You may ask the question, sir, after placing even numbers in A delta B, why you want to bother about odd numbers? Obviously, it is a common question asked by student, right? Yes, friends. The reason why you are taking odd numbers into different location means you have to ensure that no other element is there in A delta B except even numbers. Okay. We have to ensure that A delta B does not contain any other number except even numbers. So, therefore, in order to ensure that you have to place odd numbers into different location. Therefore, the total task will be completed by completing this task followed by this task. So, therefore, the correct answer for this question is, therefore, 2 power n ways we can place even numbers into A delta B followed by 2 power n ways we can place odd numbers into remaining place. Clear, friends? Therefore, the final answer is 2 to the power of 2n. Once again, I am explaining why you want to focusing on odd numbers. The reason is simple. I placed all even numbers into A delta B in 2 power n ways. But I want only even numbers. No other element should contain A delta B. It means that I have to separate remaining odd numbers into some other location. Some other location means either A intersection B location or A union B whole bar location. Therefore, all odd numbers must be placed into remaining location so that I can ensure that A delta B contains even numbers. That's enough, friends. Okay. No further discussion for this problem. Yeah, copy it, friends.